Hi everyone, welcome to Business Education and Research. This video presents the meaning, key features and the advantages of stratified random sampling. Stratified random sampling is a method of sampling that involves dividing a population into smaller groups known as strata. These strata are formed based on shared attributes or characteristics. From each stratum, a random sample is selected using methods like simple random sampling. This approach ensures representation from each subgroup in the total sample. Purpose of stratification. The main goal is to ensure that each subgroup within the population is adequately represented in the sample. By doing this, the method aims to increase the statistical efficiency and provide more accurate and detailed insights about the entire population. Selection of strata. The process of forming strata is crucial. It requires a deep understanding of the population's characteristics. The strata are generally formed based on key variables that are relevant to the research, such as age, income, education level, etc. Representation of minority groups. This method is particularly useful when the population includes minority groups that may not be adequately represented in simple random sampling. By stratifying, researchers ensure these groups are included in the sample in proportion to their presence in the population. Enhancing comparability. Stratified sampling allows for more effective comparison between different subgroups within the population. Since the sample from each stratum is representative of that specific subgroup, comparisons and contrast can be more accurately drawn. Enhanced representativeness. Stratified random sampling involves accuracy by ensuring that each subgroup within the population is adequately represented in the sample. This is particularly important in diverse populations where subgroups may have distinct characteristics. By capturing these subgroups proportionately, the sampling reflects the true composition of the population, leading to more accurate results. Reduction in bias. This method reduces the likelihood of sampling bias. In simple random sampling, there is a chance that certain subgroups might be underrepresented or overrepresented by purely chance. Stratified random sampling, by design, includes all significant subgroups, thereby minimizing the risk and leading to a more unbiased sample. Improved accuracy in estimates. When subgroups within the population show significant variability, stratified random sampling allows for more precise estimates of population parameters. Since the method accounts for the inherent differences between strata, the overall variance within the sample is reduced, leading to more precise and accurate estimates. Tailored sampling for each stratum. Stratified sampling allows for using different sampling techniques within each stratum to enhance accuracy. For instance, if one stratum is more heterogeneous than others, a larger or more targeted sample from each stratum can be taken to ensure accurate representation. This flexibility in sampling techniques contributes to the overall accuracy of the research. Stratified random sampling is effective for large and diverse populations. In large and diverse populations, simple random sampling might miss out on capturing the differences and variations within subgroups. Stratified random sampling, by dividing the population into relevant strata, ensure that even the smallest or most distinct groups are represented. This is crucial in studies where understanding the differences between subgroups is as important as understanding the overall population. Stratified random sampling minimizes the variability within each stratum by grouping similar elements together. Since each stratum is more homogeneous compared to the entire population, the variability within these groups is lower. This reduction in internal variability leads to more precise estimates of the population parameters, thereby reducing the overall sampling error. By creating strata that are internally consistent, this method allows for more reliable and accurate analysis of each subgroup. When each stratum represents a specific segment of the population accurately, the findings from each stratum are less prone to the sampling error. This is particularly beneficial in studies where subgroups analysis is as critical as the overall analysis. Stratified random sampling allows researchers to control the size and composition of each stratum. By allocating more resources to sample from strata with greater variability or from smaller, more critical subgroups, researchers can effectively reduce the sampling error that might arise from underrepresentation or overvariation within those data. In stratified random sampling, the overall population estimate is derived by appropriately weighing the estimates from each stratum. This approach recognizes and adjusts for the different variations within each subgroup, leading to more accurate estimation of the population parameters. As a result, the sampling error associated with population parameter estimate is significantly reduced. For populations containing rare or small subgroups, simple random sampling might fail to include these groups adequately, leading to high sampling error. Whereas stratified random sampling, by ensuring these rare groups from their own strata, guarantees their representation in the sample. This is crucial for studies where the perspectives or characteristics of these smaller groups are essential for the research outcomes. Stratified random sampling allows researchers to focus their efforts on specific well-defined subgroups. This targeted approach means that time and resources are not wasted on collecting data from less relevant or overrepresented sections of the population. By concentrating on data that are critical to the research objectives, the overall efficiency of the data collection process is improved. In many cases, by ensuring that each stratum is proportionately represented, stratified sampling can reduce the total sample size needed for reliable results compared to simple random sampling. This can significantly cut down on field work time, associated costs such as travel expenses, personal hours, especially when the subgroups are geographically dispersed. Stratified sampling allows for the allocation of resources in a manner that is proportional to the stratum's variability or importance. For instance, more resources can be allocated to strata that are more heterogeneous or crucial to the study's objectives. These strategic allocation ensure that resources are not wasted on oversampling from more homogeneous or less critical strata. By ensuring that each subgroup within the population is adequately represented, stratified random sampling often achieves greater precision in estimates without a proportionate increase in cost. This is because the method leverages the inherent structure of the population to gain efficiency rather than simply increasing the sample size. The pre-sampling phase of stratified random sampling, where the population is divided into strata, allows for more accurate planning and budgeting. Researchers can anticipate the resources needed for each stratum and allocate funds more effectively. This planning helps avoid unexpected expenses and ensure that the study remains within the budget. Stratified random sampling enables researchers to conduct a thorough analysis of each stratum separately. This in-depth examination allows for the identification and understanding of unique characteristics and patterns within each subgroup. Such detailed analysis is particularly beneficial in studies where the behavior or responses of specific segments of the population are of interest. By dividing the population into distinct strata, this method facilitates comparative analysis between different subgroups. Researchers can easily compare and contrast results across strata, gaining insight into how different segments of the population vary in terms of the variables being studied. This comparison can lead to more refined and informed interpretations of the data. In fields like marketing or public policy, understanding the specific needs and characteristics of different segments of the population is crucial. Stratified random sampling provides the detailed data necessary to develop tailored strategies and interventions for each subgroup, enhancing the effectiveness of these initiatives. Stratified sampling can reveal patterns and trends that might be obscured in simple random sample of the entire population. By isolating each subgroup, it becomes easier to identify unique trends within these groups, which might otherwise be diluted or missed when considering the aggregate data. The detailed analysis of strata ensure that the findings are more representative of the entire population. This method improves the reliability, that is consistency, and validity, that is accuracy, of the research results, as the conclusions drawn are based on a comprehensive examination of all relevant segments of the population.